So here we have oxidation reduction reactions, yet another way to categorize a reaction. In an oxidation reduction reaction, the electrons are being transferred. And in these reactions, one of the substances is oxidized and the other is reduced. The subject that's oxidized loses electrons, and the reduction gains electrons. Now, there are a couple different ways to keep track of these. One is oil rig. Oxidation is loss. OIL. And RIG stands for reduction is gain. You can also think of is when you gain an electron, you're gaining something that's negative, and so that's going to make a reduction. It's going to reduce your charge. So let's look at an example and see if we can figure out which thing is being oxidized and which thing is being reduced. If we look at our first reaction here, we see that we've got two coppers combining with oxygen to make copper oxide. This is a synthesis reaction, but it's also an oxidation reduction reaction. So we can divide this into two half reactions. We can look at the copper, which is an element and has no charge. And we can look over here, and this copper oxide is ionic, and it's composed of a copper with a positive 2 charge and an oxygen with a minus 2 charge. Because it's an ionic compound, I know it's ionic because it's a metal and a nonmetal, and we've got these charges. So we have something with no charge, and it's going to become positively charged. Make that copper ion. So we can say that it has lost an electron. That's how it got a positive charge. It had to lose 2 electrons, actually. Okay, so let's look at the oxygen. The oxygen here is an element. It's not charged. Put a 0 on top of it. It's going to form this ion with a negative charge, so it had to have gained 2 electrons. So this is oxidized and this is reduced. So you can't just lose electrons or gain electrons in isolation. You have to have another compound nearby willing to take them. So let's look at the next one. Here's lithium fluoride. We know that the product here is ionic, and it's composed of lithium with 1 positive charge and fluoride with 1 negative charge. So we can divide this into 2 reactions. We're going to do half, these are called half reactions. We can say we've got lithium metal, which has no charge, and we're making lithium the ion that has a positive charge. So it's lost an electron, and so it's oxidized. The fluorine, also an element, it has no charge when it's 2 fluorines attached to each other, becomes negatively charged, and it has gained electrons to do that. And so it is reduced. So let's look at this last one. It's a little more complicated. We've got zinc. It's going to react with copper sulfate, making zinc sulfate and copper. So this is an ionic compound. It's composed of copper with a positive 2 charge and sulfur, and a polyatomic ion sulfur with a negative 2 charge. The zinc has a positive 2 charge, and the sulfate a -2 charge. So we can look at what's happening here. Oh, and by the way, this is a single replacement reaction, if you were trying to place that. Okay, so we can divide this into half reactions. On the product side, we've got a regular old zinc. It's an element, it doesn't have any charge. On the positive, on the product side, zinc has a +2 charge. So it must have lost electrons. So it was oxidized. Let's look at the copper. The copper on the product side has a +2. It's an ion. On the reactant side. This is the reactant side. Copper, +2. If we look at copper on the product side, we see that it's an element. It has no charge. So to go from +2 to no charge, it must have gained a negative charge. It gained electrons, and so it was reduced. If you look at the sulfate, it's -2 on the reactant side, and it's also -2 on the product side. So it was neither oxidized or reduced. Oxidation and reduction reactions are very common in biological systems, and they may involve the addition of oxygen or the loss of hydrogen. Reduction may involve the removal of oxygen or the gain of hydrogen.